Hello everybody. Once again I am here with you for the another characteristics of the radio receiver, and who are looking for the fourth unit, that is communication electronics, in which we are basically learning for the characteristics of radio receiver. And the first one characteristics, that is sensitivity, we have seen. And now which is the related with that sensitivity, here is the another one, that is selectivity is there. Now while selecting the signal, some sort of when fixed frequency we selecting and rejecting the another frequencies, and that's why the importance of the selectivity is doing two jobs: selecting a fixed suitable frequency and rejecting the unwanted frequency. So this is what the exactly the selectivity is there. And to understand this selectivity of any receiver, radio receiver, basically the selectivity is nothing but to be ability to reject the unwanted signal, as I told you. And this selectivity is expressed as shown here below in this curve. If you look at this curve, which is to be showing us where the receiver tuned for the basically at this stage. And here some sort of typical selectivity curve is there. And just to look at this deviation from the resonant frequency kilohertz, and receiver tuned at the 950 kilohertz. And whatever the narrower will when this curve will be narrower, that shows the highest selectivity is there. That is the fine selectivity is there. So let's see, we will see in detail also. And it is going to be similarly, the whatever be the we are using the circuitry in the sensitivity, the same circuitry is going to be used as a dummy antenna, and replacing the load resistance at the loudspeaker. That same part is there as far as selectivity is going to be concerned. And in this case where the uh, basically we are looking for at this curve is showing us, that is how what is exactly the selectivity is there. Now this in this case showing that the minimum rejection is 950 kilohertz, that is at a tuned frequency. And we are rejecting but rejection, if you look at the increases as the input signal frequency is going to be deviates. Now as the deviating from this 950, the whatever be the rejection is going to be there, which is going to be shows that particularly receiver offers a minimum rejection at 950, that is here minimum rejection is at 950, and the maximum rejection is at upper side. And that is what the wherever this curve is narrower, that some sort of selectivity is fine or superb at that stage. Now as it is tuned for the 950 kilohertz and the selectivity of the super heterodyne receiver is determined by the frequency response characteristics of the IF amplifier. The IF is playing very important role in this case also. The responses of mixer and the RF amplifier stages also plays a small but significant role in this case, as we know that in the super heterodyne, this IF amplifier and this mixer, where this particularly adjustable difference in the frequencies, that is intermediate frequency we can say, that some sort of giving us removing the TRF receivers, whatever be the drawbacks in this using this IF amplifier. And that's why this plays an important role in this selectivity also. This RF amplifier and the mixers also the playing the role, important role in this selectivity. Now the selectivity decides the adjacent channel rejection of the receivers. And here it is tuned for the 950. And it is also showing this graph that as it is going to be receiver tuned at 950, and it is for the different ranges, the rejection is nearer to 950 rejection is maximum, and this is somehow the measurement of the selectivity conditions measurements are as same as for the sensitivity, as shown. I already told you in the same circuitry is going to be used, but the whatever be the standard input adjusted to the standard output at nearly for the generator output frequency to the 950 kilohertz. Now the generator output frequency is deviated above and below 950 kilohertz is suitable steps, and that somehow showing us that rejection is maximum at the right side and the left side of the 950 kilohertz, and every time the generator output voltage is adjusted, and note down the get the standard output should be 50 milliwatt as previously done in the sensitivity part. Same circuitry is going to be used, the same thing is there, only the frequency is adjusted at the 950 kilohertz and the deviation is measured at the selected frequency range. Means here in this selectivity we have to find out what is the exactly the rejection at the selected frequency range, and that gives us particularly how fine the selection is there. The attenuation is calculated and the plotted as shown in the figure above, that shown in the previous figure, and using this procedure we can measure the selectivity at any carrier frequency. For the different carrier frequency even we can obtain for below different selected frequency also, and the observation table for the attenuation is measured in this case. And if you look at this observation table, it is clearly deviation from the resonant frequency which is we selected. Suppose 950 or 850 we selected, how the rejection is there or the attenuation is there for 2 kilohertz, 4 kilohertz, 10 kilohertz, in that case we measure. And the selectivity at a receiver goes on increasing as the selectivity curve uh, is becomes more and more narrower, and that narrower curve is definitely showing us that the increase in the selectivity. So this is what the same part or the same circuitry we have to use for the radio receivers another characteristics, that is called as a selectivity. Again, thank you for joining this session. Be at home and be safe. Thank you.